Hello, and welcome to the Subnational Gender Inequality Index tutorial. This tutorial first serves as a guide to understanding UNDP's Gender Inequality Index. And second, it is a tutorial on how to calculate the Subnational Gender Inequality Index that was created specifically for Vietnam. So let's begin. Here we have an overview of the topics that will be covered in this tutorial. First, we will give an introduction to UNDP's GII, including the sub-indices and the calculations used to create this index. We will then use this framework to calculate the 2017 Gender Inequality Index scores for Vietnam, Cambodia, and Thailand. Next, we will go through how to edit the UNDP framework to calculate the Subnational Gender Inequality Index for Vietnam. The main learning objectives for this section are to teach users how to add variables to the index, as well as how to add an additional sub-indices to the overall Gender Inequality Index. The Subnational Gender Inequality Index is based on the original Gender Inequality Index created by UNDP. UNDP's Gender Inequality Index was introduced to the HDR in 2010 and measures inequalities in achievement between men and women in 3 dimensions of human development: reproductive health, which is measured by maternal mortality ratio and adolescent birth rates; empowerment, which is measured by the proportion of parliamentary seats occupied by females and the proportion of adult females and males aged 25 years and older with at least some secondary education; and the labor market, which is measured by labor force participation rates of female and male populations aged 15 years and older. In order to follow along with this tutorial, you will need access to the tutorial guide and the associated data files. There are 2 Excel files associated with this tutorial. The first is labeled UNDP_GII_calculations, and the second is called Vietnam_GII_calculations. In this exercise, you will work with the original Gender Inequality Index framework to calculate the GII for a sample of countries. For the purposes of this exercise, please note the following abbreviations. To begin, let's open the Excel file named UNDP_GII_calculations. This Excel file should contain information on how to calculate gender inequality with example data from 3 countries already inputted into the formula. Navigate to the box labeled Dimensional Indices by Gender. This box contains information for calculating each index, in this case, reproductive health, empowerment, and labor market for both men and women. Try clicking on each of the cells under each dimensional index to explore how the value was calculated. For example, click on the first female entry under the reproductive health index to see how that index was calculated. For this index, male reproductive health is always represented as 1. Female reproductive health is calculated by taking the square root of 10 over the maternal mortality ratio times 1 over the adolescent birth rate. It should be noted that as higher maternal mortality suggests poorer maternal health, for the maternal mortality ratio, the maximum value is truncated at 1,000 deaths per 100,000 live births, and the minimum value at 10. The rationale is that countries where maternal mortality ratios exceed 1,000 do not differ in their inability to create conditions and support for maternal health, and that countries with 10 or fewer deaths per 100,000 births are performing at essentially the same level, and that small differences are random. In Excel, the measurement of female reproductive health is obtained through the equation indicated by the red arrow on your screen. This equation is what we call an if statement. The if statement executes a certain section of code if the test expression is evaluated true. If not, it moves on to the next section and evaluates to see if that is true, and so on and so forth. Let's break down this equation a little further. So first, Excel would look to see if the first statement is true. And the first statement says that if the input maternal mortality ratio is less than 10, then I would want to take the square root of the product of 1 over 10 times 1 over the adolescent birth rate. If this statement is not true, then Excel would move on to the second statement and see if that was true. And this statement reads, if the input maternal mortality ratio is greater than 1,000, then we would take the square root of the product of 1 over 1,000 times 1 over the adolescent birth rate. If neither of the above statements are true, then we would move on to the last statement, which simply says to take the square root of the product of 10 over the maternal mortality ratio times 1 over the adolescent birth rate. So just to recap, we just learned about how to calculate the reproductive health index. And we learned that calculating the reproductive health index for females is very different than men. For the females, we want to have a longer if statement to go over the different complexities of using maternal mortality ratios and adolescent birth rates. Whereas for the men, we always just put 1. Now let's move on to the empowerment index. Click on the first entry under female, which is located at Q10, to see the calculation in Excel for female empowerment index. Now click on the male and see how they're different. Let's take a moment to break each of these down. For this index, male and female empowerment are calculated by taking the square root of the parliamentary representation divided by 100 multiplied by the secondary educational attainment divided by 100. In Excel, male empowerment is calculated using the same equation. However, the female empowerment calculation uses another if statement. Let's look at our diagram again to break down this if statement so that we know exactly what we're calculating here. Again, we can go through each of these if statements one by one. Luckily for the female empowerment index, there's only 2 statements to go through. So the first statement says, if the share of parliament seats is equal to 0, then we write 0.1. And then we take the square root of 0.001 multiplied by 1 over the secondary educational attainment. If that is not true, meaning that if there is at least 1 share of parliamentary seats that belongs to a woman, then we take the square root of the product of the share of parliamentary seats divided by 100 times the secondary educational attainment for females divided by 100. So we've now calculated the reproductive health index and the empowerment index. The last index that is left to be calculated for the UNDP's Gender Inequality Index is a labor market index for both males and females. So you can click on S10 or T10 to look at the first indicators for male and female labor market indices. And the equation up here is pretty simple. We're just taking the labor force participation rate for each gender and dividing it by 100. So here in this first entry, we can look, we've got 64 divided by 100, and that's 0.64. As well as here in the male labor market index, we have 85 as the percentage of the labor force participation rate. That divided by 100 is going to be 0.85. Now that the dimensional indices have been calculated for each gender, we must aggregate across dimensions within each gender group using the geometric mean. In mathematics, the geometric mean is a mean or average, which indicates the central tendency or typical value of a set of numbers by using the product of their values, as opposed to the arithmetic mean, which uses their sum. The geometric mean is defined as the nth root of the product of n numbers. For instance, the geometric mean of 2 numbers, say 2 and 8, is just the square root of their product. That is, the square root of 2 times 8 equals 4. As another example, the geometric mean of 3 numbers, 4, 1, and 16, is the cubed root of their product, which is taking the cubed root of 4 times 1 times 16, which also equals 4. Navigate to the box labeled Indices within and across genders, and to the male and female fields under Gender Indices. These columns contain information for calculating the geometric mean of all the sub-indices for each gender. Try clicking on each of the cells under the gender indices to explore how the values are calculated. You can easily see when you click on the first entry under the female gender indices that we are taking the geometric mean of each of the indices that we had calculated before. Since there are 3 indices, we know that the geometric mean is simply taking the cubed root of the product of all 3 of these indices. And the same thing is happening with the male indice. We are taking the cubed root of each of the product of the male reproductive health times male empowerment times male labor market index. The next step is to aggregate across gender groups using a harmonic mean. The female and male indices are aggregated by the harmonic mean to create the equally distributed gender index. Using the harmonic mean of within group geometric means captures the inequality between women and men and adjusts for associations between dimensions. That is, it accounts for the overlapping inequalities in dimensions. In mathematics, the harmonic mean is the reciprocal of the arithmetic mean of the reciprocals. Well, that's a lot of reciprocals. The formula is the harmonic mean equals n over 1 over a plus 1 over b plus 1 over c, where a, b, and c are the values and n is how many values. Well, if that equation seems really complicated, it's actually pretty easy to evaluate in Excel. To take the harmonic mean, we simply use the equation equals harmonic mean, and we enter all of our variables. So let's navigate now to our spreadsheet again, and we're in indices within and across genders, and we're under the accounting for inequality. And here we have the first value. And if you look at this first entry, the equation for it is up here, and it's equals harmonic mean, and we're looking at V10 and W10, which are just the first entries for the female and male gender indices. So this equation will take the harmonic mean between our male and female indices, which were calculated from our dimensional indices by gender. And it's the same all the way down. Next, we need to calculate the geometric mean of the arithmetic means for each indicator. The reference standard for computing inequality is obtained by aggregating female and male indices using equal weights, thus treating the genders equally, and then aggregating the indices across dimensions for each gender that we calculated earlier. The figure on the left shows the calculation for the geometric mean of the arithmetic means, when health is represented by the equation below it, and then empowerment, and then labor force participation rate. The arrow on the right indicates the equation as it looks in Excel. Now that you know how to calculate the geometric mean of the arithmetic means, let's take a look at how this influences the equation that we have in our Excel spreadsheet. So if you go to the section of indices within and across genders and you select the first entry under treating genders equally, you can then go up to the formula bar to see how that was calculated. And you can see in here that these are actually all the variables from the dimensional indices. So O10 is the first entry for reproductive health index for females, whereas P10 is the reproductive health first entry for males, and so on and so forth. Our last step is to calculate the final index by comparing the equally distributed gender index to the reference standard using the equation 1 minus the harmonic mean over the geometric mean of the arithmetic mean. Obtaining the final gender inequality index in Excel is really easy. So let's go over to the column labeled Gender Inequality Index over here and click on the first entry. Here we can see that we're taking 1 minus the first entry for accounting for inequality over our first entry for treating genders equally. And that's how we calculate the Gender Inequality Index according to the UNDP methodology. Now that you understand how to translate UNDP's GII formula into Excel, try inputting variables to calculate the 2017 GII for Vietnam, Cambodia, and Thailand. The first step is to navigate to the first entry under the Female Reproductive Health Index in our example data. So that's cell O10. right-click on this cell and hit Copy. Next, navigate to the Female Reproductive Health Index for Vietnam, which is cell 027. Right-click and hit Paste. This should extend the formula into your new cells and give you the output value of 0.82. Click on the bottom right-hand corner of the cell containing your new value and drag the green box down 2 cells to autofill the results for Cambodia and Thailand. Now you can repeat these steps for each of the dimensional indices by gender. Remembering that the reproductive health index for the men is just simply 1, so we can input that value here. Next, we'll repeat these steps for each of the indices within and across genders. And last, we'll repeat these steps to calculate the final GII for each country. You can then input your results into your table on your worksheet tutorial. You can also compare the results that you got here today to the UNDP website, where you can see the input variables for the calculations, as well as the score that they gave each of the countries. Now that you've learned how to create UNDP's Gender Inequality Index, let's move on to the next exercise. The purpose of this exercise is to demonstrate how to edit UNDP's Gender Inequality Index formula to create a subnational Gender Inequality Index for Vietnam. The new index has improved upon UNDP's framework by amending the Empowerment Index to include the share of women's parliamentary seats, People's Council seats, and the share of female in senior ministerial and government positions, which we can see here. This is the Empowerment Index, and we can look and see that there are 3 variables in here instead of just 2. And those relate directly back to these input variables over here. In addition, the index parses out education from the Empowerment Index into a new education index that includes secondary educational attainment, some secondary educational attainment, complete secondary educational attainment, and literacy rates. And we can see the new education index and how it was formed here. In order to complete this exercise, you will need to open the following Excel file. The Excel file should be named VNM_calculations19. The Excel file contains 3 different calculations. The first tab has the completed formula for calculating the subnational Gender Inequality Index. The second tab is called Adding Variables, and this is an example of how we're going to add a variable to the index. And the last tab is called Adding Indices, and this will demonstrate how to add a new index to the Gender Inequality Index. So let's start with a demonstration about how to add new variables to an existing dimensional indices by gender. The steps for calculating the index are exactly the same as outlined in the Exploring UNDP UNDP's GII in Excel that we just went over. The only changes you need to make when adding variables to a dimensional index are to the dimensional index itself. All other calculations, such as the harmonic mean, the geometric mean of the arithmetic means, and the final GII will stay exactly the same. So in this example, I would like to add a new variable to our labor force participation rate index. Currently, I can go over to the labor force participation rates index, and I can see that there's only one variable, one input variable going into the female and male indices. So here, all this calculation is saying is it's taking the percentage of labor force for each gender and dividing it by 100. But I have another variable that I would like to input into this index to make it a little bit more robust. So if we can see over here, the example index, and I've got percentage of female in this example and percentage of males. So what I would want to do to adjust this is I would want to go over to my dimensional index, and now the formula has changed. If you can remember how we were calculating before, we take each of the variables and then we want to take the nth root of those variables. So if I had 3 variables, I would be taking the cubed root of the product of all of them. But because I only have 2, I'm just going to take the square root. So here I'm going to change the formula to equals, and we need a few parentheses. We're going to put square root because there's only 2 input variables. I'm going to get a few parentheses in here. So the first one, again, we still want this labor force participation rate index. So here, divided by 100. And we want the product of that and the other input variable that we have, which is this new example LFPR index, or variable, sorry. And that is also divided by 100. We want to close those brackets out and hit enter. And instead of inputting this formula in for every single input entry that I have here, I can just simply double click on the right-hand corner of that variable that I just made. And we'll want to do the same thing for the males. Okay, so we'll go back up to the formula bar and we're going to change the formula to equals square root. And we want to make sure that we select the male variables times our new input variable divided by 100 and close out those brackets. All right. And if you can see all of these moving over here, all of your indices within and across genders, as well as your gender inequality index, those calculations will automatically adjust to your new formula. So you don't have to edit anything over here when you're adding new variables over here. The only time you'll have to edit these equations is when you add a new indice, and that's what we're going to go over next. Now that we've learned how to add a new variable to an existing indice, let's look at what happens when we add a new indice, a dimensional indice, to our equation. So go to the second tab called Adding Indices. In here we can see, well, let's toggle back and forth so you can see. Here we don't have our educational indice, but we know that we have that in our final subnational gender inequality index. So in our final subnational gender inequality index, it looks a little bit more like this, where empowerment is represented by the share of parliamentary seats, share of people's council seats, and share of senior ministerial government staff positions. And then we added a new educational index that has some secondary education, complete secondary education, and literacy rates. So there are 3 variables that go into this dimensional indice. And we can look at how those 3 variables create that index over here. So if we go to the first entry under female in the education index, we can see that we're taking each of those indices, the product of them, and taking the cubed root of them. And that's for both male and female. And that's how we create our educational index. Okay, well, how does that impact the indices within and across genders? Well, if we first go to our gender indices, female and male, this is where we took the geometric mean of all of our sub-indices. And if you look in this first entry, you can see that there are only 3 input dimensional indices. So if we would like to incorporate the education index, we have to add it to this equation. And that's really simple to do. So we click on the first entry, and then we go up to our formula bar, and we add in the first entry from the new index. And again, we can, instead of entering that for every single entry below, we can just double click and it should change the rest of the equations. Now we want to do the same thing for the male gender indices. Go to the first entry, enter the formula bar, and enter in the first entry from the education index. Okay, we can see that all four are there now. Now, what about this accounting for equality? That was when we took the harmonic mean. If you look back into the accounting for inequality measurement, you can see here that it's just taking the harmonic mean between the gender indices. So these two variables that you just edited. So we do not need to do any additional calculations to this equation over here because all the editing of the equation happens within the gender indices. It will always take the harmonic mean between the female and male gender indices. The next equation that we want to go to is the geometric mean of the arithmetic means, and that's our treating genders equally. And here we can see that we have a longer, much more difficult equation where we're taking the arithmetic mean, so it's the sum between the two male and female variables for every indices, as well as the geometric mean, which is the product here to the nth root, which is 3 because we only have 3 variables. Okay, so when I look at this, what I see is that we have a pattern here. We are taking each indice, so the reproductive health indice for male and female, and dividing by 2 because there's only one entry for females and one entry for males. And that's happening with each index. So we need to change that to adjust for our new indice. And we'll do that right at the end here. So we will multiply. Want to make sure that we have the right amount of brackets. Female educational index plus male educational index divided by 2. Okay. And there's only one more variable that you need to change in here. So if we can see that you're taking it by the nth root, so that's how many input variables you have going in. And instead of 3 now, we have 4. So 1, 2, 3, 4. So we're going to take to the 4th root, or 1 over 4. Right? And you should have gotten 0.520. And then you can double click and go all the way down. And it should change the entire index on the right. And that's how you add an index to your subnational gender inequality index. And that concludes the end of this training video. Thank you for participating, and I hope you learned a lot.